to work. As I mentioned, the primary task here is to install ammonia jumpers that are routed from the lab to node 3. These jumpers will provide cooling to node 3. However, for thermal protection, they need to route a thermal blanket around these jumpers. So their first task will be to install that thermal blanket. You'll see that show up here. It looks like a large Y-shaped blanket. Here we have some training footage of Bob and Nick installing that blanket. As you can see, this is a pretty large blanket, but these guys have done a really good job of finding a good way to pack this in the bag and pull it out and secure it to the space station. They'll use an EVA tether called an adjustable equipment tether to secure these before installing the ammonia jumpers on top of it. You can see Bob securing his end. And now you see the blanket is pretty much in place. Nick is getting his end secured. Their next task will be to route the 4 ammonia jumpers that route from the lab to node 3. As I mentioned, these jumpers will provide cooling. Here you can see Bob routing one end to Nick. Nick will connect his end at the US lab. Bob will connect his end using a fluid quick disconnect on node 3. Once that's complete, they'll close the thermal blanket around all 4 lines. And in order to provide adequate clearance for a module that's going to be arriving on the final space shuttle flight, there's a particular routing path for these lines that we want to make sure we adhere to. So the crew will be using a gap spanner, which is a special EVA tether that can stay outside almost indefinitely. And they'll be using that to secure the MLI, or the thermal blanket, and the ammonia jumpers in place. Finally, the crew members will open up one half of the ammonia cooling system that requires throwing 2 bales on fluid quick disconnects on the lab side and 2 on the node 3 side. The other half of the system, or the redundant part of the system, will be activated on EVA 3. Once this is complete, they will put the thermal blankets back in place and then head out to node 3 for some node 3 outfitting. Bob's first task will be to install a keel pin cover. The keel pin is a structural attach point that holds node 3 into the shuttle payload bay. He'll be putting a thermal cover on it to prevent condensation from building up inside of node 3. He'll then translate to the nadir common berthing mechanism on node 3, where he'll open up a flap that will allow camera views of the cupola when it's being berthed to this port. He'll also open up a series of 4 pedal covers. These covers protect the sealing surface on this port. Here you can see Bob opening up one of these covers in training. From there, Bob will continue installing thermal blankets. There'll be a total of 4 thermal blankets covering trunnions. These trunnions are used to secure node 3 into the payload bay for launch. Again, the need for these covers is to prevent condensation from building up in the module. Here you can see Bob installing one of the covers in place. There's a section that covers the trunnion itself, and then an area that we call the scuff plate also needs to be covered. That's directly underneath that in this view. So there's 2 on the aft side and 2 on the forward side. These covers are going to be secured using Velcro and what we call quarter-turn fasteners. So the quarter-turn fasteners are a special bolt that will provide a grounding path in case any charge is built up in the thermal cover. While Bob is doing this, Nick is going to be installing a series of handrails. These EVA handrails could not be launched in place because they interfered with structure in the orbiter payload bay. He has a total of 8 handrails that he'll install. Once he gets these handrails installed, it'll create a nice path to his next work site. Here he will be installing a non-propulsive vent. This vent will be used to depressurize cupola before it is relocated to its final home on the nadir side of node 3. The acronym for The non-propulsive vent is NPV. It's also been dubbed the Nick Patrick valve because he has installed this so many times in training. Here you can see that vent. It has a T shape to prevent any change in attitude of the space station during venting. From there, the final task of EVA2 will be to install a gap spanner. This is a translational aid that helps the crew translate around the ammonia jumpers that they just installed. This is also the same tool that they've been using to hold the ammonia jumpers and thermal blanket in place. That completes EVA2. Bob and Nick will clean up their work sites and head back into the joint airlock. They'll have 2 days before their third and final EVA. Before we start talking about EVA3, I'd like to introduce you to a piece of hardware that you'll probably see a lot of on EVA2. This is a fluid quick disconnect. At the end of each of the ammonia jumpers, you'll find one of